Thanks everybody for joining us today on the webinar of the theme that we're trying to achieve the highest accuracy drone surveying using Share's 5-lens oblique camera on using it on the DJI M300 drone without using a ground control. And with me, I have our partner Share UAV Technology. They're from China and they're collaborating with DJI on the 5-lens oblique camera promotion along with the drones. And they are represented today by Mia Lu. She is the overseas sales manager. So I will drive through a quick agenda of what we are planning to discuss today is an introduction about Aeromotus, DJI, and Share. Then some brief about the oblique imagery, oblique photogrammetry, and the products from Share cameras. The workflow, what is involved in using a 5-lens camera along with the Matrice 300. We will also go through the tool manager, which will help you to do planning by using the 5-lens oblique camera. The work efficiency from Share cameras, a few case studies and 3D modeling results. We will also be showing across the outputs which we have generated on DJI Terra software and Bentley context capture and certain applications. This is what we're trying to cover on this webinar. So to give you an introduction, as most of us would have seen in our previous webinars, and you must be popularly knowing about DJI Enterprise and Aeromotus. So DJI Enterprise as the world's leading drone manufacturer with innovative drone solutions for architecture, engineering, construction, oil and gas, and for the solar PV sectors and different market segments. Aeromotus is the DJI Enterprise partner for Middle East and Africa. Primarily, we're based in Dubai. We are an end-to-end drone solutions provider with the solutions covering from enterprise drones, cameras, LiDAR sensors, and trainings, as well as with other softwares and platforms. We are focused on the drone surveying and oblique photogrammetry. So Share is one of our partners. We are the sole distributor for Share sensors in the region, and we are primarily focused. They're primarily focused on drone surveying, oblique photogrammetry. The main two models what we're going to look after is the 102S and 202S for the DJI Matrice drone for high precision surveying, mapping, and without setting a ground control. So what is basically we're trying to show across is the efficient drone surveying and mapping with oblique photogrammetry with no ground controls points used. To give you a brief on Share is established in 2016. We've been focusing on drone surveying, oblique photogrammetry for years. They have few cameras which has been compatible with the DJI Matrice drones, as well as it can also be used along with the VTOL and other brand drones as well. So they have launched the SDK, the cameras, which can work with the DJI Pilot app for high precise surveying and mapping without setting up the GCPs. The main generation of the surveying has changed with the use of 5-lens camera by giving it a better, easier operation with lower labor cost, high efficiency, and high accuracy. So to most of us who would know what is oblique photogrammetry, a little bit brief on what is oblique photogrammetry. Oblique photogrammetry is a technology in the international mapping and remote sensing industry. It captures 5 images actually from 5 different angles. So one is orthogonal and 4 oblique directions. So this is basically what the focus subject of the webinar is to talk about oblique photogrammetry sensors. The main products to start with is we do have the 102S, that's the 5-lens oblique camera, then the 202S, that's a higher resolution full frame as well as oblique camera, and then the 6100, that's a full frame sensor as well. It is basically customized on the SkyPod, and as you can see, this is a easy fit in. It can go directly on the M300 on the SkyPod connector itself. So on the specification wise, PSD 102S and 202S, if you see it, we have the 5 lens camera. The quantity of lens is 5 pieces, focal length with 25 mm, and then 35 mm 4 units. Effective pixels is 24.3 megapixel, giving you a total pixels of 120 megapixel. The sensor is ABS C with the pixel size of 6000 by 4000. The storage is built in because it's the built-in SD card, so you will have a cable along with the sensor to download the data because it's from different 5 different cameras, so it also has the position data. It is compatible with the M210 and M300. Now on the Share 202 Pro, it also has 5 lens oblique lens. The total pixel is 210 with the full frame sensor size. The capacity of storage is 1280, 1.2 terabyte approximately. Weight is 1.2 kilogram. That's compatible on the M300 as well as an M600 and other drones. So Share 610, again, it's a full frame sensor with a 61 megapixel, and the storage capacity is 256, compatible with M210 and M300. What's the workflow involved in this camera? So what generally has to happen is that you will have the aircraft in terms of M300, and you can have a Skypod direct connectivity with the any of those Share cameras on the Matrice 300 and 200 series. And then you can also have, along with the Share, there's another variant of the product called a Share, which can go on the non-DJI aircrafts as well. So the main tools what you would need as a complete package is the M300 drone, which will be using the DJI Pilot as our automation plan, along with the 5 lens camera, a 102S or a 202S. It also captures the data with the position data of each of the imagery from each of the lens, and then you have to use a shared data manager to download the data from the sensor before it gets into DJI Terra. And then in the DJI Terra, you can use it for the 3D modeling and the generation of 2D and 3D outputs, which I will be again showing you in the next few slides. So the step, very simple steps. You need to do a insert the gimbal on the Skypod of M300. It's fairly straightforward, and then you will see an icon on the DJI Pilot app itself. You can also do the grid mission planning on the DJI Pilot as the existing mission planning, and select the camera as a custom camera with the Share sensor. Insert the camera settings on the DJI Pilot app, and it will start doing the grid settings and mission planning accordingly, and you will be able to see what is the level of distance, estimated time, waypoints, number of photos, areas. Once you have done, then you can use a Type-C cable which can be connected on computer, and there is no need to pull out any SD cards. So the data will be communicated to the Share data manager before it gets into the DJI Terra. So what the Share data manager does is basically it writes the position information on each of the image before it's actually used on the processing. So it can be copying the data from the SD card towards the computer at a speed of 300 megabytes per second. There is also a tool manager along with the sensor. So once you get the sensor, you will have a tool, a flight planning tool. I would say more of a project planning tool where you can select the camera model, and it pulls up the same specifications and the pixel size. And you can also insert your KML file in this. So you can input your KML file to get the actual survey area, and also decide what is the side and front overlap, and to calculate the GSD before you go on site with the relevant altitude. So if you look at the screen, you can see that at an altitude of 133 meter, you are able to get a GSD of 1.5 centimeter at an 80-75 overlap settings. And also you will be able to get the number of images, what is going to be final data captured on site within this particular time zone. Once you're finished doing the planning, then you can actually import the data, the process data into DJI Terra for modeling directly. So the workflow is quite seamless. So you have to use the mapping area before flying, then use the DJI Pilot to create a flight mission, use the data, share data manager to copy the data, process it in DJI Terra, and output the 3D modeling results. So we have some data sets which we have processed using Terra and the cameras, which I will take you through on the Terra environment directly. To get in before that, everybody would be interested to know what is the efficiency table in terms of using a 5-lens camera compared to the traditional surveying cameras. So if you're looking at the productivity on site, if the flying mission is at 96 meters and you're able to cover an area of, let's say in one mission, about 0.35 square kilometer, and if you do 14 missions with M300, because each of the mission of M300 is approximately 40 minutes, 40 to 43 minutes with the payload, and keeping the same overlap ratio, you will be able to cover 5.3 square kilometers using a 5-lens oblique camera, and with the definitely more number of imagery and more site features. So as you go higher, you will still be able to get a very accurate GSD, 3 centimeter up to 5 centimeter. You could get at 320 meters above ground or above surface level at a speed of 15 meters per second. So it's actually much more faster in terms of data capture because of the M300 mission time, and plus it has got a 5 image capture at orthogonal as well as at the 4 different directions. So it helps you to cover more area with more better GSD and also with the better features from the site. A similar work for efficiency you could see for the 202S sensor. Of course, 202 sensor is a very, very specialized application where you can go much more higher than the 102S with a higher speed. Covering the area will be much more higher, a higher amount of area in a per day productivity. Again, it depends on specialized applications. So as you see that you can even get a 5 centimeter GSD at 442 meters. Flying height with a 15 meters per second speed with M300. So with that settings, you will be able to produce you'll be able to do a surveying for 24 square kilometers in a day with 14 missions. So 14 missions is approximately 200 minutes of flying in a day. So it could go more as your team works. 610 is basically a full frame sensor, which is almost like 61 megapixel of each of images. The GSD level is quite good. It's very much accurate compared to the traditional surveying cameras. It's the advantage here is that you get a better GSD at a higher speed, which is not possible in many of the other cameras or other drone sensors. So you will be able to produce more area with a higher level of resolution and accuracy. Okay, just to give you a comparison on the difference of using a regular cameras on, let's say, on a VTOL or on a quadcopter drone, average production is 2 square kilometer a day. That's in terms of a 2D or a 3D grid mission. Whereas if you use a Matrice 300 with the sensor, with the entry level sensor, that is 102S, we're talking about 8 square kilometer per day. So the level of number of days, if you look at a coverage of 100 square kilometers project, you could finish in 13 days with the 5-lens camera and the Matrice 300 compared to the other drone platforms with regular surveying cameras. So we're trying to reduce the site time. Of course, the data will be much more bigger, but the processing time will not be substantially higher because the softwares are able to process much more faster. So you're able to save about 37 days of your site time in production. Now, let's go on some active cases where we have done some case studies about 3D model accuracy. So first of the case is one of the projects where we have flown at 110 meters with achieving a GSD of 1.25 with 80-70 overlap, speed of 10 meters per second. The number of photos were 3,680. In usual drone flights, where if you use the regular cameras other than Matrice 300 and share sensor, you would get maybe 1/5 of this images. That means you're reducing the resolution, so you might miss some very minute features on site, which are actually 3D enabled, 3D required, 3D model required. So we're talking about 19 minutes of this particular area. So you could cover using this particular in 19 minutes, and the level of images and the calibrated position. So this is a kind of summary of the quality report, what comes out from DJI Terra, where you will be able to see the images have been inputted for processing, what is images with the position, how many have used the image position. So you will see that's true. The georeferencing RMS, root mean square error as well, and the total SFM time, that's 52 minutes. So that's basically the processing time which has been taken. Now, I will try to share the DJI Terra platform. So I will show you some of the outputs which I have from the Terra itself. So DJI Terra, as if anybody wouldn't know, DJI Terra is a DJI's software for aerial photogrammetry, used for drone imagery processing, for not only for DJI drones but for other non-DJI cameras as well. But so this has been a quite popular software over the last year or so, and you can import images. So let me show you the interface itself. So you're able to do different type of missions. So if you go to a mission, you are able to do a flight route mission on the Phantom series. This is the flight route mission, which is specifically now available for Phantom RTK drones. It would be later on available for the Matrice in the future updates. Right now it's being used for reconstruction. It's been processing for 2D orthomosaic and DSM, 2D multispectral map, and 3D model. So one of the projects which I have kept the data here is that if you can import it, and once you process the data, you will be able to see your aero triangulation, and then you will be able to see also point cloud. That's a 3D point cloud in LAS file. So you can see the level of density of points. It's quite good compared to many other softwares what you see in across. And then also you will be able to see your height element in the same. You can output these formats and use it in Civil 3D or CAD or any other industry software, expert softwares. You can also export the model. The model is available at the moment in LOD, OSGB, PLY, and OBJ format, as well as in Supermap format as well. So these are formats available on the Terra. So if you have the share sensor, you can use the Terra license to process and get your outputs. So now, so what I've done is that here you can do the annotations and measurements here as well. So let's go to the annotation screen and see what's the sort of volume you're talking here. Let's just give you an idea about it. So select a polygon, and you have an option to select from the base plane or the lowest, the mean plane or the lowest points. If you like select it, let's save. So you can get the values here, because these are coordinates now from the UTM-50N. So you will be able to generate volume reports from Terra. You can export the volume reports as well. So this is one of the outputs from the 202 camera sensor asset. So you will be seeing the high resolution features here from the site, and you can filter this and create a DTM if you wish from the expert softwares or any other CAD related softwares itself. Right. So that was on the DJI Terra process models. Then I'm also having an output on a Bentley context capture. So I will just show you on the Bentley context capture as well. So this is a process model from the Share 202 sensor. This is a project which was done, and this is mainly to see about the level of sand movement and if there is an encroachment to the site. You can still, this is a context capture viewer, so you are able to do the measurements in terms of coordinates, distance, surface, and volume. So that's definitely possible on this particular surface. So you will be able to see the perimeter, area, cut, fill, volume, and you can use it for your reporting sake as well. So the level of detail is quite very much impressive compared to the regular cameras. So you will be able to see the resolution of the imagery. So that's why the number of images are more, but definitely the results are different from the regular cameras itself. Cool. So these are some of the imageries on different environments from the share sensors. Just to give you a resolution idea about the what is the sort of resolution it can take: 120 megapixel, 124 megapixel, as well as 210. The main key applications of share sensor can be for cadastral surveying and mapping, topographic surveying, smart city, construction site and progress monitoring, public safety. Yes, there are some applications which can be used for public safety as well. Emergency command in terms of any natural calamities, river management, and minings. Some of the applications, as I said, so you can use this data of this particular dense data to do classification of city, I mean the buildings and different layers in Bentley or in other similar kind of softwares where you can do layers for different type of features what you need. You can also do engineering management in terms of monitoring of structures, monitoring of movements, public safety in terms of doing any analysis of the existing locations of buildings, and it's more for urban and city development and modeling. So that's primarily the thing about the share sensor. So I actually have covered the share sensor and the drone itself. So Matrice 300, to most of you would be knowing because we have covered Matrice 300 in a couple of earlier webinars as well. So Matrice 300 usually operates on a pair, and it's a mission done with two batteries. So it flies between 40 to 43 minutes with the payloads. And so what you need as a package to use the share sensor is that you need the drone, that's M300 or M210 or a vertical takeoff drone, and then you need to select which of the cameras. Ideally, I would say to start is 102S is quite a very efficient sensor for most of the applications. And then again, it depends on your project budget and your project resolution. So you can get anywhere between 1 centimeter to 5 centimeter between flying heights of 150 to 500 meters. So that's the kind of variation in flying heights you'll be able to get it in that. Okay, that's all from today's. So you can see the level of detail what you can get from a 20 photographs, 20 imagery is this is the amount of image what you can get. So you see the 3D model, the level of vegetation you see here. So uh, if there was a question that what is a sort of vegetation coverage, so this is basically as the oblique camera can do. So I'm believing that it does a lot of good job in terms of elevations. But again, if you're looking at just the ground level below the canopy, below the tree, then that's something which a lidar can be possibly doing. But it's not possible by an aerial photogrammetry or an oblique. But again, depending on if you want to count the number of trees, if you want to do any sort of vegetation mapping, yes, this is a heightened sensor which can be used. And there are other one more data set which probably will be also interesting. So if you look at This is one of the other data sets which we have from 202S. The point cloud, you can see the level of density of the point cloud and the features. And the height element again. You can see the model. Of course, the 3D model is absolutely different. We do have other cameras within the DJI basket. I ran into webinars last few weeks on P1, and we do have other cameras as well. But again, 5-lens oblique camera is a specialized sensor, and this is for high resolution and very high accuracy applications where you want to fly at very high altitudes and while keeping the same level of GST. So that's mainly what we are aiming at, pitching the 5-lens camera. Okay, so that was about it. And is there any other questions in between? Cool. Okay. There's a question about how about integration with GIS other than Supermap for developing 3D data. So if you're talking about outputs from Terra, yes, you can generate outputs, can be used for GIS. If you're looking at importing it into ArcGIS Pro, yes, we do have format that can go directly into ArcGIS Pro. So you get ortho maps, you get DSMs, you get point cloud in LAS file, and .obj, .osgp. So different formats which can be imported into specialist softwares. Cool. I think yeah, that's